This is Geometry, Chapter 5, Section 2, in which we will be studying the medians and altitudes of triangles. Last section we talked about perpendicular bisectors and angle bisectors. This time we're going to be talking about some other useful segments, the first of which is called the median. What the median of a triangle does is it goes from the vertex of a triangle to the midpoint of the opposite side. Don't get this confused with perpendicular bisector because it doesn't have to be perpendicular. All it has to do is go from the corner of the triangle to the middle of the opposite side. Okay. Every triangle has three medians. And just like we talked about last time, there's a point of concurrency for those three medians where they all meet, and it's called the centroid. Okay. And what the centroid theorem tells us is that the centroid of a triangle is 2/3 of the distance from the vertex to the midpoint on the opposite side. So if I'm looking for, say for example here, FC is 15, then point P is 2/3 of the way from C to F. Well, from C to P will be 2/3 of the distance, and from P to F will be the other 1/3. So first I'm going to find PC. PC is 2/3 of the distance. 2/3 times 15 is 10. So PC is 10. Now FP is what's left. 15 for the whole line minus 10 leaves FP to be 5. Now suppose they want us to find the coordinates of the centroid of a triangle. And they tell us the coordinates of 3 points, the 3 vertices. Okay. Our objective is to find the point where the median lines intersect. Well, that means we're going to need to find the midpoints first. So I'm going to pick 2 points. I picked the second and third one. If you want, you can name these A, B, and C or something like that so that it makes it easier to talk about them. But I'm going to find the midpoint between those 2 points. And the midpoint, using the midpoint formula, is 2, 5. Now I've got a midpoint and a vertex. I can find the slope. Okay, 8 minus 5 over negative 4 minus 2 gives me 3 over negative 6, which is negative 1/2. Okay, now I have a slope. I have a slope and I have a point to plug into the point-slope equation. Okay, we're doing all of this stuff to figure out the equation of one of the median lines. Because if we can find the equation for one of the median lines and we can find the equation for the second, then we can find out where they cross. Now from here it's a little bit of simple distribute and move things over. So we distributed, now move the 8 over, and we've got one equation. Okay. Now I need to pick another side to work from to find the midpoint for. So I'm going to pick the first and third points. No special reason, just because I did. So I do a little midpoint work. Find out that the midpoint is a half, 6.5. Now I need the slope between here and the point I didn't use. So 5 minus 6.5 over -1 minus a half. A little arithmetic tells me the slope is 1. Point slope form. Y minus 5 equals 1 times x plus 1, using the point from the vertex again. Distribute the 1 and then move the 5 over. Okay. Now I've got my two equations. I could get the third one if I wanted to, but if I'm looking for the point of intersection, all I really need is 2. So I'm going to just get 2 and not go to the trouble of getting the third one. So I've got my two equations. Now I know how to solve this. I can do elimination method, I can do substitution method, I can do graphing. Well, I'm going to choose to do substitution since they're both set up so nicely. Y equals stuff, substitute this in place of that y. Move some things around and find out that x is 0. If I substitute 0 back in for x, and I picked the bottom equation, you could have picked the top one, but I picked the bottom. I get y equals 6, which tells me that the centroid is that point where they intersected, 0, 6. All right, a lot of things happened in that problem. First thing we had to do, I'm going to jump back over and just talk through it again. Find a midpoint. Find the slope between the vertex and the midpoint. Get the equation and get it down to y equals. Get to slope-intercept form to make things easy later. Then pick a different side. So I picked the first and third. Midpoint. Slope. Okay. Point slope form to get to the y-intercept form, y equals mx plus b form. Then find where those two intersect. Find x, find y, and there's your centroid. Okay. Yes, there's a lot going on there, but the good news is you already know how to do every single bit of it. We've done it several times along the way here. Now there's another kind of segment we need to talk about called the altitude. Okay. The altitude is a perpendicular segment from the vertex to the line containing the opposite side, and we say that way for a reason. You have to go perpendicular to the opposite side, but that may not be possible inside the triangle. So sometimes you have to draw your altitude outside the triangle. Every triangle has 3 altitudes, and the point of concurrency is called the orthocenter. Now be aware the orthocenter could be inside, could be outside, could be on the triangle. And the altitude could be inside the triangle. It could be on the outside. Or if you're talking about a right triangle, it could be one of the sides. Okay. So let's find ourselves an orthocenter. All right, we're going to have to go through a similar process to find the orthocenter. But we don't need a midpoint for that. So the first thing I'm going to do is find, and this time they gave us letters to talk about, I'm going to find the slope of segment FH. So 8 minus 5 over negative 4 minus 5 cleans up to negative a third. Okay. Now, since the altitude is going to be perpendicular to that, what I'm really interested in is a slope of 3. And that's going to be a slope of 3 for a line going through point G, the point that I didn't use here. So substituting into point slope form, distribute and collect. I've got an equation for one altitude. Now I need to do a second one. So I picked FG this time. Again, no special reason, just I picked those two. A little arithmetic for finding the slope. Now remember, we need the perpendicular slope, so we need the opposite reciprocal. So the opposite reciprocal of negative 1 is 1. Makes life easier there. Point slope form with point H, because H wasn't one of the points that we picked. Distribute the 1, move the 5 over. That one was easy enough to clean up. Now we've got two equations. I'm going to substitute this stuff in for that y. Subtract the x over, divide, and I get the value for x to be negative 4. Substitute that back in. I'm going to plug it into this equation because it makes it easy. If x is negative 4, then y is negative 4. So the orthocenter, pay no attention to the sign that was there, the orthocenter is negative 4, negative 4. Okay. Again, you had to find a slope, do the negative reciprocal to get to an equation, find another slope, do the negative reciprocal, get to an equation, solve the two equations together to get your point. Okay. So medians go to the midpoint, altitudes are perpendicular. Hopefully, as always, if you had questions along the way, you wrote those down, bring them in with you, and we will see you in class.